I think we can start and introduce everyone and then, yeah. Thank you so much for everybody to be here today. We're very excited about this webinar promoted by the AESP Education Committee. And today we're going to talk about integrating sustainability into core engineering courses. And we have these wonderful panelists here today. We have Cindy Anderson, Cristiano Reis, Eileen Jensen, Ashish Borgaonkar, and Pinar Omur Osbeck. And we're going to be hearing about them. They work in different types of universities, different types of coursework, different levels of students. So we have like a pretty diverse panel here today to talk about this. So I'm going to introduce us as moderators, and then I'm also going to introduce all the panelists at once. So then everything will flow after that, like each panelist will move on to the next. Okay, so I am Fernanda Cruz Rios, and I'm assistant professor at Drexel at the Civil, Architectural, and Environmental Engineering department. I'm trained as an architect, and then I did a PhD in Civil, Environmental, and Sustainable Engineering at ASU. My main research interests are circular economy, sustainable buildings and cities, designing for circularity and for resilience, life cycle assessment, and engineering education. And I'm a part of the fourth cohort of this mini grant that we're probably going to hear about today. The goal is to infuse sustainability into core engineering courses using the Engineering for One Planet framework. And as our co-moderator here today, we have Lindsay Payne. She's an associate professor of practice in sustainability engineering, in environmental engineering. She's also a former director of service learning at Purdue. Her expertise is at an intersection of sustainability, teaching and learning, and engagement, focusing on transdisciplinary decision-making in community-engaged design. She also has worked professionally in the nonprofit and secondary education sectors, and she currently serves on multiple community-based environmental boards. Thank you, Lindsay, for helping out today for us to moderate this wonderful panel. First, we're going to be hearing from Cindy Anderson. Cindy is the co-founder of the Engineering for One Planet initiative and the Engineering for One Planet strategy consultant with the Lemelson Foundation. As a sustainability consultant, Cindy specializes in innovative sustainability-focused research and curriculum projects for academic institutions, nonprofits, government, and industry. She also has taught thousands of people through courses and workshops around the world and online in the fields of biology, sustainability, and biomimicry. Her prior work also includes launching the world's first online interdisciplinary MA in sustainable design, funding the Biomimicry Institute's higher education program, and conducting climate impact research on seabirds in the Antarctic and Arctic. Then we are going to be hearing from Dr. Cristiano Reis. Cristiano is an assistant professor of chemical engineering at Howard University, and his work bridges bioprocess engineering, sustainable process design, and engineering education. His research focuses on waste and methane valorization, technical economic and life cycle assessment, and the integration of sustainability and green chemistry into chemical engineering curricula. Before joining Howard, he also held an academic and research leadership roles at Earth University in Costa Rica. And after Cristiano, we're going to be hearing from Dr. Eileen Jensen. Eileen is a professor and chair of the Department of Civil Architectural Engineering at Lawrence Technological University. Her expertise is at the intersection of material sustainability, engineering education, and interdisciplinary collaboration, focusing on the characterization of structural concrete materials and the integration of sustainability and entrepreneurial mindsets into engineering curricula. She's also active in secondary education outreach through regional high school and middle school programs. She currently serves on multiple community-based environmental boards as well, including the City of Southfield Sustainability Action Plan Community Advisory Board. Then we're going to hear from Dr. Ashish Borgaonkar. So Ashish he's an assistant professor of engineering education at New Jersey Institute of Technologies, Newark College of Engineering. His research focuses on interdisciplinary curriculum, translation of advanced research topics and novel technologies into engineering education, preparing the next generation STEM workforce through experiential learning, academic enrichment, and workforce development. He is also the founding director of the New Jersey Institute of Technology's Grand Challenge Scholar Program, which is endorsed by the National Academy of Engineering. Ashish is also recipient of multiple awards, most recently the AEESP 2025 Distinguished Teaching Award, and also the New Jersey Institute of Technology's Excellence in Lower Division Undergrad Instruction Award. And then finally, last but not least, we're going to be hearing from Dr. Pinar Omar Osbeck. Pinar is a teaching professor and associate department head for undergraduate programs in the Department of Civil and Environmental Engineering at Colorado State University. So her current work focuses on engineering education with emphasis on integrating sustainability, ethics, systems thinking, and inclusive teaching practices into engineering curricula through active and reflective learning approaches. She also contributes to national faculty development initiatives through her service with American Society of Civil Engineers and the Keen Network, alongside broader scholarship in engineering education and assessment.
All right. Thank you very much. So I am here to give you a few ground rules today for our presentations. We're going to be using the Q&A feature for questions during our panelists' talk. So if you can't find that, there's 3 little dots near the bottom of your screen where it says more. That's where it will pop up. It's right near there so you can see it. So pop that up if you have questions. We ask that you stay muted during the presentations, but if you'd like to turn your video on, we'd love to see you. And then I will be collecting questions. I will have some ready if you all have them as well and want to share them when the panelists are done. You are more than happy to do that. And you'll also be able to unmute at that time. So without further ado, I'm going to turn it over to Cindy and let her begin.
Okay, thank you so much for that amazing introduction to everybody on the panel. I'm Cindy Anderson. I'm Engineering for One Planet co-founder and strategy consultant with the Lemelson Foundation, as was already shared. And I'm really excited to be here today to share generally about the Engineering for One Planet initiative, but really to share a little bit more detail, especially about our free open source teaching resources from Engineering for One Planet, or EOP, as we like to say. So thank you again for everybody that's here today. We know that your lives are so busy, and so to take the time to be with us synchronously is really exciting. We love having participants live. Thank you to the AEESP Education Committee for the invitation to present with you today, and also just big thank you for the panelists. I'm super excited to learn more about what they're doing in their classrooms, and as I'm sure each of you are. I'm going to just cover a little bit about the EOP initiative, talk to you about our free online open source resources, tell you a little bit about EOP funding and awards that are available, and then share just a few ways you can get involved with EOP starting today if you wish. So what is Engineering for One Planet, or EOP? Well, our vision is that sustainability will become a core tenet of the engineering profession, no matter the discipline. And really the goal is overarchingly to transform engineering education so that every engineer is equipped and prepared to ensure that their work contributes to a healthy world for lifetimes to come. And again, no matter the discipline. And you can learn even more about what I'm talking about today on our EOP website, or just by going to engineeringforoneplanet.org. So just a kind of high-level overview of where we've gone in the past several years. We launched Engineering for One Planet back in 2020 with the original launch of the EOP framework, which has now gone through 2 different revisions. But just some metrics about what's been accomplished since that time. We've had 80 Engineering for One Planet grantees, and that includes both from our mini grant program as well as NSF funded the NSF funded initiatives, and that includes 24 minority serving institutions and includes 6 HBCUs. So we're really excited about the expansiveness of the program. All of these institutions are from the US. Over 500 faculty are using the EOP framework that we know of, and this is through our grantee program. And we know that over 600 courses have been modified using the EOP framework. And over 50,000 students now have been impacted by EOP since the launch in 2020. So we're feeling like we're not doing too badly considering we launched during COVID. And again, these are all numbers based on our EOP grantees. There are many people that are using our resources that we don't even know about because everything's available for free online and also in the Creative Commons, so they can be used however faculty want to use them. So how are we doing this at work? Well, we're really trying to affect systems change, as I mentioned before, and we've decided on sort of this 3 interrelated approach method. So it's a 3-pronged method. The first is to really help faculty to simplify curricular innovation. So when we were doing our preliminary research before we launched EOP, we heard a lot from engineering faculty that there wasn't space in their courses to introduce new content, especially sustainability, something that's complicated that maybe they didn't learn about. So we're trying really hard with our growing community of experts and faculty and students and industry members and governmental members to really co-create curricular resources to make it as easy as possible to bring sustainability into engineering coursework. So we'll talk more about that. The second way we're trying to affect change is through acceleration of curricular innovation. We're doing that through funding and award opportunities because, again, back when we were doing our early research, we learned that faculty really need to be recognized for the work that they're doing, and also they need financial support. And so just want to underscore that we're trying to do this both in large and small ways with these different granting programs. And then lastly, we have a volunteer action network that works together to collaborate and move the Engineer for One Planet initiative forward with various projects. And we also collaborate externally from outside of the EOP network to advance this initiative. So I'm going to just talk about those first 2 approaches because I think they're the most relevant for this webinar today. But I do encourage you to contact me through LinkedIn if you want to learn any more about anything I'm saying or to dive deeper into anything else. I'm happy to connect with you. So again, the first way we're doing this is simplifying curricular innovation through the development of community co-created resources. And I really just want to underscore that we're not creating these resources in a bubble. These are all co-created with community members. So experts, teaching faculty, students, people from across industry are contributing to these resources so that they're very useful. And then also they've been vetted. So these are resources that have been tested and tried, and you're going to hear from some of the people on the panel today about how they've been using some of these resources. So the first resource I wanted to share with you, if you're not familiar, is the EOP, or Engineering for One Planet framework. And it's really the cornerstone of the EOP initiative. As I said before, we launched this in 2020. It really covers a plethora of student learning outcomes that the community decided that really all engineering students should be exposed to and hopefully acquire by the time they graduate in order to really be effectively prepared to face the biggest challenges that they'll face, are humanity's greatest challenges, such as climate change and all of the other big challenges that are facing us. As I said before, we launched in 2020, it was revised in 22, and we just like a month ago, released the new version from this year. We collected feedback all of last year, and now we have had over 230 contributors to the EOP framework alone. And just a big thank yous to those people that have contributed to this from our community. But just to give you a sense of the input that we've received just through the 2025 feedback call, we had over 400 direct comments to our EOP framework. We conducted over 40 expert interviews and student interviews, and we had surveys and focus groups. And we really worked one-on-one with different individuals to help us dive more deeply into certain themes that we felt were really important to highlight in this version, such as climate, energy, materials design, etc. So, and if you're interested in learning about the changes to the EOP framework, we do have a little video that's available now online. So I just encourage you to watch it. It's just a 6-minute video that explains what we changed in a high-level way. So the EOP framework, as I said, there's 94 core and supplemental learning outcomes across 9 different topic areas. And these include topic areas that are really sustainability focused, including systems thinking at the center of the framework, but also it includes what we call professional or leadership or durable skills. So 2 of the topic areas cover critical thinking and communication and teamwork, which we're hearing over and over again from industry that these are critical skills that they want engineering students to have when they enter the workforce. A couple other things about the framework that is important to highlight for you. All of the learning outcomes have been mapped to ABET student outcomes to make it, again, as easy as possible to bring into the classroom, but also to hopefully help faculty to achieve their accreditation standards. It's this version of the framework, the 2026 version, is now mapped to all 17 UN SDGs and also to Bloom's taxonomy. The framework it's important to know it's not prescriptive. You can really use the framework however you want. You could take one student learning outcome and bring that into a course, and that could be it. Or sometimes people take the framework and use it as an entire checklist to either develop a whole new program or overhaul an existing program. So a couple of examples of that. So University of Calgary in Canada, they created a new program which was launched in fall of 2023, an interdisciplinary program that brought faculty from mechanical, chemical, civil, energy, geomatics, and electrical engineering together. And they used the EOP framework as one of their major frameworks to create this entirely new program, which is called the Bachelor of Science in Sustainable Systems Engineering. And really excitingly, just 2 years later, they won the Quanser Sustainability Award. So they were the 2025 recipients. Another example of a program that used the EOP framework is from the University of Twente in the Netherlands. They created a program called CLEAR, which is chemical engineering and environmental engineering. They just launched this in 2026, and you can see from this image that they heavily leaned on the EOP framework in order to create their program structure. And this is just a picture of the award-winning team, because just this year they won 1.2 million euros to continue this work in this program and expand what they're doing. So we're really excited for these programs. So in addition to the EOP framework, we also have several companion teaching guides. And so what we learned as soon as we launched the framework, many people came to us and said, this is fabulous. Okay, this is what students need to learn. How do we do it? How do we teach them? And so we immediately went to work to create how-to teaching guides. So there are so many, I don't have time to dive into everyone today, but I'll just briefly cover them. There's the Comprehensive Guide to Teaching Core Learning Outcomes, where we provide videos, student prompts or questions for students, examples of student work, step-by-step activities of what to do in your classroom. And all of that is included for every single core learning outcome for the EOP framework in this guide. The Quick Start Activity Guide, we dive into one core learning outcome from the framework from each of the 9 different topic areas. And we go into that very deeply, and we give step-by-step methodologies of what to bring into your classroom and how to do it, and provide supporting resources, etc. And then we have 2 more guides here, the orange and the green guide. These were created by faculty within our EOP network and universe. One was created at a conference at the ASEE conference. Another was created through workshops. And these are specifically faculty created teaching activities. And then we're really excited about the new climate education guide we just launched in March. And I want to say a big thank you to the people that worked on this new guide that we launched on World Engineering Day with climate experts and teaching faculty and engineers from industry, and then our 18 collaborative partners that helped us with this program. So check out that guide if you haven't seen these before. This is a brand new one. Very quickly, I wanted to share just a couple of examples of what you can find in these guides. So in this the climate education guide, there's an example from a professor and interim chair of civil engineering, technology, environmental management, and safety at RIT. And her course was structural steel design. The course level is 400 level course. And in the EOP framework, she went to the design topic area and chose one learning outcome, core learning outcome here, which is written out. And I've just circled the areas to call out the icon for the Bloom's taxonomy. And then at the bottom here, you can see another call out for the ABET mapping, which is the orange circle, and the UN SDGs mapping. So we try to get really specific about how these courses are mapped to what they're doing in the classroom. Another example from the Green Guide is a course, Basic Mathematical Modeling, a 100 level course by a professor of mathematical sciences at NYU. And in this course activity, he looked at the learning outcome from environmental literacy. And the course activity is really about looking at across the 30-year, or sorry, it's a CO2 emissions from Hawaii's Mauna Loa Observatory dating back to 1950. So very exciting step-by-step activities in these guides. Okay, now I'm running out of time here, so I'm just going to jump into a couple of touch on a couple of things that you may be interested in knowing outside of the resources. So we have a number of recognition and funding opportunities. So there's the ABET Lemelson EOP Innovation and Sustainability Award, which comes with a $10,000 cash prize. It's open to any ABET accredited STEM program internationally. So this is one of the things that we're doing outside of the US as well. So nominations for that are coming up here, April 20th. So I encourage you to apply for that. Also, our ASEE EOP mini grant program. Applications are open, will be open this fall. We just launched our newest cohort, and that comes with an $8,000 grant. And really the important thing is mentorship and community of practice. And then we also have our National Science Foundation Lemelson Initiative in environmental and so to bring environmental and social sustainability into engineering education. And that's a rolling deadline. So we encourage you to apply at any time. So a few ways you can join us in my last minute of being able to present. Like I said before, please do think about applying or nominating someone for the ABET Lemelson EOP Award coming up here, deadline April 20th. Also, I wanted to share about the Quanser Global Sustainability Award. As I mentioned, University of Calgary won it last year. This is open now for nominations, which are due by June 30th. And then lastly, I encourage you to share Engineering for One Planet's online resources with your peers. Please do just pass on the word, share with your peers. And then lastly, a call to action if you're interested. We're looking for feedback on engineering textbooks. So we're going to try to integrate Engineering for One Planet and sustainability into more engineering textbooks. So we're looking for people's feedback, like which engineering textbooks do you use? Which ones are popular to you? Which ones do your students like? We're going to try to reach out to publishers and authors in order to integrate the sustainability into them. So there's a short form here. It takes no more than 5 minutes to share any information you're interested in sharing. And then lastly, I just encourage you to sign up for our newsletter, connect with us on LinkedIn. This is where you can get breaking news about grants and awards and see what we're up to. I know that was a lot really in a short period of time. Happy to take questions after all the panelists go. And then it's my pleasure to introduce and pass the mic over to Cristiano Reis, and let's hear from him and what he's been doing in his classrooms. Thank you.
Cristiano, I think you're muted.
Oh, now it's going. I wasn't able to unmute myself for some reason. All right. So thank you, everyone. Thank you, Cindy, for passing me the mic. I'm assuming everyone can see my slides. So thank you again for the invitation to join this panel. My name is Cristiano Reis, and I'm assistant professor in chemical engineering at Howard University. I want to share one quick example of how I've been thinking about integrating sustainability into core engineering education using chemical engineering process design as a focal point for this. So my goal today will be to show how this work connects institutional context from Howard, curriculum structure, and the recent EOP mini grant program that I'm part of. I want to start with Howard because institutional context matters a lot for why this work feels important. Howard University is an HBCU with a mission grounded in truth and service. It is currently the only HBCU with Carnegie R1 status. So it brings together a strong legacy of access, leadership, and public purpose with a high level of research activity. For me, that context shapes how I think about sustainability education. At Howard, and that also aligns with me, sustainability is not just about environmental performance in a very narrow sense. It is also about how engineering decisions will affect people, communities, infrastructure, health, long-term well-being to all communities. So integrating sustainability into engineering education fits naturally with Howard's broader mission of combining academic rigor with societal impacts. Starting from that mission, the next question naturally becomes how sustainability can actually show up in teaching, right? As Cindy mentioned, one common challenge in engineering education is that sustainability was often or is often treated as something extra, something that students see in a special module or an elective, and rather than this being part of the core curriculum. And this is where the EOP will come. What I've been trying to think about sustainability is as part of how students already learn how to make engineering decisions. And my examples today come primarily from chemical engineering, but I think this underlying idea can be applied much more broadly. So the real objective will not be to add one more topic to the curriculum, but to help students make sustainability part of how they define problems, how they compare alternatives, and how they justify their solutions. I want to show this very briefly to give a sense of the front end of the chemical engineering program at Howard. This is very similar to many chemical engineering programs in the US. In the first 2 years, students are building up the core technical foundation through math, chemistry, physics, and intro to engineering courses. They also begin identifying with the discipline through, particularly through introduction to chemical engineering. And by the sophomore years, they start moving to math and energy balance, which really begins to transition into chemical engineering problem solving. So this is the stage where technical base is being built that later supports design and sustainability reasoning. Moving on to junior and senior years, this is where process design becomes especially useful. By the time that the students reach this part of the curriculum, they have already taken courses in thermodynamics, in transport, in kinetics, and by the senior year, they're also taking separations and process control. In other words, they are no longer learning isolated concepts and they are being asked to integrate them in process design. So this is why process design became for me a strong entry point for sustainability integration. The course already asks students to make choices under very tight constraints and to justify those choices in terms of performance, in terms of economics, safety, and feasibility. So sustainability for me, it fits naturally into that conversation because it adds another layer to how students will evaluate trade-offs rather than feeling completely like a separate topic. And I apologize for this text-heavy slide, but this is the EOP mini grant poster that we presented earlier on this year, considering the scope of our work. Okay, so the project, just as Fernanda, I'm part of the cohort 4 of the program. And the central idea was to integrate EOP learning outcomes across on a longitudinal way across the chemical engineering curriculum in a very intentional and scaffolded way. Just like as process design, not treating sustainability as a standalone topic or something that is only addressed in one single course. The motivation, this aligns with what I was saying. It is very straightforward. chemical engineers, they make decisions that directly influence energy use, emissions, water demand, safety, material choices that overall impact communities. And because of that, students need very structured opportunities to connect this technical decision making with broader sustainability reasoning. So the project asks, how can we help students encounter these ideas across the curriculum with increasing depth over time? We show in the poster that the project focused on a few courses as initial entry point for this. We start with Intro to Chemical Engineering Design at the freshman level, heat transfer at the junior level, and process design at the senior level. The idea again is to build this in a scaffolded way where students will not see sustainability once, but would rather revisit sustainability through different dimensions using the EOP framework as basis as they move through the program. In terms of the method for this, we combined curriculum mapping to see where our courses currently fit within the framework. This helped us target some course revisions and some early assessment of this process. We then, considering the mapping, we use the tool to see how many of the learning outcomes currently existed in our courses, and then we revisited those to make sure that EOP became a little bit more explicit and more aligned with the outcomes. In terms of the actual activities in the classroom, we're introducing the framework at the beginning of the semester to these courses so the students had a clear idea of the framework for thinking about the whole process. The poster also shows one of the more interesting results from the mapping exercise is that the different courses that we're targeting with this award emphasize different parts of the framework. Some courses contribute more to system thinking, some courses contribute more to design, while others connect more strongly to communication, to environmental literacy, or to social responsibility. And that is an important takeaway for my team because it reinforces the idea that sustainability integration should be longitudinal in the engineering curriculum. We should not expect a single course to address every EOP dimension. At least that was our initial conclusion, but rather as a collaborative approach as students move through the curriculum. Finally, the project include an evidence of learning component through the pre and post analysis, and the goal will then be using this pre and post over a number of years to begin understanding how the students approach engineering problems that involve these trade-offs among all these factors that I mentioned earlier: production, cost, environmental impact, and also the community concerns. This mini grant was very generous to give us both a curricular strategy and also the initial assessment structure and helping create a foundation for broader integration moving forward. Looking ahead, the next steps that I'm particularly working on is to deepen the work in process design through system thinking. One resource that I'm currently using is based on the American Chemical Society, the ACS. They have under the Green Chemistry Institute some teaching modules, and they have a very complete system thinking teaching module. And what I especially consider useful about that module is that it gives the students the language and the structure of thinking beyond the immediate unit operation or design decisions, and move this towards a broader system effect trade-offs and societal implications, considering the chemistry and the chemical engineering world. For process design, that matters particularly because students are already working across reactors, across separations, across utility costs, and all of this under a number of constraints. So system thinking can help students make these broader connections a little bit more explicit. I am running out of time over here, but I also plan to expand the assessment of this, connecting to some standardized sustainability knowledge assessments, and of course keep dissemination to the community of learning. And with this, I would like to end up my presentation and pass the mic to Ellen.
Thank you very much. I think we need to get to the other end of the presentation. There we go. All right, thank you. So I will dive into a little bit more details for a first year class. We also went through the exercise of mapping out how we could integrate curriculum throughout the sustainability throughout the curriculum, but I'm going to focus on our first year work. So what we notice is when the students are reaching their capstone, they are really doing an outstanding job designing the systems that we have. And I'm focusing here on architectural engineering and civil engineering. But back in the early 2020s, 21 area, we did notice that the students did miss out on really linking their designs to the specific site, whether that was thinking about how they fit into the larger community, thinking about how perhaps the solutions could have had an alternative shape, and also very important, what would the stakeholder feel about this particular solution? So those are things that we feel that the students need to learn. And we realize we cannot just dump this in the fourth year. We need to build up to that. So we leaned on the EOP framework, and as clearly you cannot hit all of the topic areas in one course. So if we were to focus on the first year, how could we create an open-ended project where we could develop these skills so that the students would be able to have a more meaningful experience both now and later? And of course, what we also wanted to do is to figure out how did that change in student learning take place, and could we actually measure that? How did they understand project priorities? So we start out with this first year class. We expect students to spend about 180 minutes a week in a 1 credit class, maybe a little bit less, but up to this amount. So we wanted to focus on a community-based project. We wanted the students to respond to an RFP and come up with a preliminary proposal. So we have 16 weeks in this course, and we divided the course into 4 modules, as you see here. And as part of the deliverable specific to the project, we did that towards the last half of the project. We have a overall conceptual design, we have impact statement, and then there is a final presentation to stakeholders. And to be able to do that assessment of student learning, we also integrated the mind maps, and you see the timing of that is the first set of mind maps are done right after the project concepts have been graded, actually have gotten feedback on that, and just before their final presentations. So to provide a little bit of context, we are located in the city of Southfield, which is a first-rank suburb to Detroit here in Michigan. So the city of Southfield is a good example for us to work with. The city of Southfield was built up starting in the 60s, really around this northwestern large freeway as we have going through the city. So we asked the students as part of some of the first activities to go out and experience the city, and thinking about specific priorities of mobility, micro and macro mobility, and how did the city encourage its residents and guests to actually get out and engage with the community, because our river is a freeway. So thinking about like how quickly did this change take place, and we bring them back like 15 years and show them what those locations looked like 15 years ago. So the efforts of the city to innovate basically innovate themselves and attract new citizens and businesses. So we had to talk a little bit about like how was the city developed. It was developed with the mindset of everybody had one or two cars. There was very little thought to micromobility. We also talk about some of the demographic changes and some of the historical drivers behind that. We talk about some of the examples that the city had implemented of best practices from micro and macro mobility, but also in terms of stormwater management. So we focus on some key areas in that space. So once they had sort of gotten a sense of where we were 10, 15 years ago, where we are now, but what do we want to inspire these students to? Well, we want them to design for the future. And in this case, we actually leverage the ASCE resources because there is a strong sense of sustainability in these resources. And the students saw what could a future city look like, and then scale that back to what we have now. So again, the focus is developing a mindset where the students think intentionally about the planning process and the conceptual design, teaching them early on to ask the how and why. We want them to think about, is it possible that there are some future needs that we need to think about that we haven't met with the current design? Can we integrate new technologies and find ways to create more sustainable solutions? So in the one case where we work directly with the city of Southfield, we have extracted what their key priorities are, and the students know this upfront for whatever project they are going to undertake. One of the projects that we started out with was the Smart Transit Center because the master plan indicated that this was a big need for the city. So we took this Greyhound bus stops, as you see in the upper left, and we wanted to make that a hub so that we integrated not only the intercity bus, but also regional bus and the local buses. So the student had to think about how did the regional buses maybe needed to be rerouted. How did we reroute some of the local bus routes such that there was better connectivity? So they had to think about it in a little bit of a big scale. So the picture on the lower left is also showing some preliminary design sketches. But students also had to evaluate some of the stormwater management best practices, and they did a current evaluation of how much runoff they had from the site. And after their solution was integrated, they saw the impact of their designs. So they get like different snapshots. Of course, they don't understand all the technical background, but they can use some of these tools to get aha moments. And also we talk a little bit about realistic costs and whatnot. Another project that we worked with is the city of Northfield, which is a neighboring city, and they have actually the first Ford Field Park that ever was in existence. But the Ford Field Park is actually divided in the east and the west, and there is a street, Griswold Street, that goes right through it. So it's very inconvenient actually to move from one side to the other, and the east side is underdeveloped as a usable park. So students were, one of the student teams decided, well, we want to improve the micromobility and the access to this particular site, and they, as first semester freshmen, did some research. How are we going to be meeting some of the local requirement for design, and how can we improve the overall safety for our users of these two park sites? And they also expanded into what would the parking lot be, what would the flow of traffic be, what would be the connection to the pathway and build out of the pathway on the east and the west side. Another team thought more about, well, the east side needs to have a better development so that you can get around the waterways. And they wanted to develop a place where guests could stand and overlook the spillway. And they went through the design, conceptual design process. They looked at different kinds of materials, sustainable materials, what's the best solution for that. But the lessons they got from walking around in the city before and thinking about what was the placemaking components or elements of those previous design, and they became very intentional about their design in that way. So we wanted to be able to measure the output of the student learning. And again, we used mind maps for that. So remember, the individual prelim mind map was just after the initial early concept proposal. And then in that same session, the students then met together as a team and created a team mind map. And then by the time of the final presentation, they are asked to, again, create an individual mind map. So we use an existing tool to score the mind maps, and depending on how complex the mind map is, the higher is the score. This is an example. This is actually reconstructed with a software package of one student's mind map at the stage of the conceptual design. And, you know, they're thinking very much about the task, the elements of the design. But then towards the end of the project, you know, even though that this is only 3 weeks later, they are already able to articulate what are the priorities, how did these priority links together. So, of course, I'm prompting them to think about environment, thinking about transit and all of that, but they have to put in all the elements. So when you're looking at the change of learning, I think what is interesting here is that as you would expect, the students have a better sense of the projects, you know, between those 2 points of the individual mind maps. But what is clear is that once the students have done the individual mind map and come together in their teams, then they are able to actually better articulate what are our common goals, what are our common solutions, so that we are able to address those priorities. And they are able to carry that through to the end of the project. So it is a way of sort of getting everybody on the same place in the project. So it's that whole thing about scaffolding, about delivering, and in this case, just-in-time learning, because that is critical for them to have a meaningful output in such a fast-paced class. So they are very focused on the physical design in the beginning, but what we are getting them to is really to have a more overall view of sustainability and what are the goals of the overall project. So it is this transition that we can make from a task-driven mindset to what I call a stakeholder inclusive mindset. And this is what is necessary to have a meaningful, I think, sustainable solution. So the EOP framework absolutely helped us frame that question, so to speak, and the mind maps helped us also measure the change in student learning. I do want to thank everyone, and I do recognize that we are speeding along here, and I would like to introduce Ashish Bogankar as the next presenter, and I hope that you have a lot of questions to all of us at the end.
Thank you. Thank you very much. Are you guys able to see my screen?
Yes.
Is this the presenter view or
No, we can see
all
the,
good?
I think we can, yeah, we can see the
Excellent.
whole.
Yeah, it's good.
Thank you. Thank you very much. So thank you for the opportunity. My name is Ashish Burgaonkar. I'll be talking to you about a few things I have done to integrate sustainability in core engineering courses. So this is a little bit about me. My focus is engineering education, experiential learning, translation of research into engineering education and curriculum. But my background and all of my education is in environmental engineering, and I maintain research in both areas in order to be able to advise students. I'm an assistant professor going up for tenure. We'll find out by the end of the month. Hopefully, I have had a few grants, and as you can notice here, many of my grants have a very strong community component, which I have been able to leverage to convince a bunch of folks to also give me some awards. So that has worked out quite well. So here is my favorite introduction slide. This is what I use when I introduce myself to the students. This sort of summarizes all the things that are very dear to me: family and friends, travel, food, teaching, STEM education, my alma maters. And there was a time when I actually played some of these sports. Now I barely find time to even follow them. But, such is life. So little bit about my place. This is where I studied, and I'm also working. It's a mid-sized school, R1 Polytechnic, extremely diverse, and an engineering education powerhouse. And we are a top 100 national university, top 50 public national university. I believe the ranks for this year are 80 and 40, which is the best we have ever achieved. We are very well known for return on investment. And my favorite one is as an NJIT alum. NJIT is very famous for admitting students from the lower socioeconomic background, and within 5 to 10 years of graduation, they have climbed up the ladder. So I'm very, very proud of this fact. So moving to the topic at hand for today, integrating sustainability into core engineering courses. Before I show you the examples of things that I have done, I wanted to touch base on these very important points. First of all, buy-in is very important. People focus a lot on students' buy-in, but instructor buy-in is equally important. You need to think this through and not add, any modules or any activities just for the sake of adding. You do not need to start from scratch. There is a lot of work that has been done, and people are sharing these resources freely, including the EOP framework that we saw. And the most important thing is that whatever you do, connect it with ABET course student learning outcomes, so that it doesn't feel like a standalone uh, on its own activity. So these are the three examples I want to talk to you about. The first one is optional components as extra credit or fourth credit opportunities. The second one is dedicated modules in required courses, which are the best sort of launch pads for these concepts, and then full-fledged sustainability focused courses. The first one, this is a seminar series we launched February of this year. This was part of our work as cohort 4 of ASE EOP mini grant. And we were doing it, but we also thought about why not give this as an extra credit for the students. The speaker, the inaugural speaker was Dr. Bufadel, who is also an AEESP member, by the way, and he spoke about resilience communities and minimizing the impact of climate change, flooding, and other things that are bothering everybody. This was very relatable. This was very well connected with multiple courses, and students took up our offer of extra credit very generously. They showed up in great numbers to the point that we had to actually go bring chairs from other rooms. And anybody who has organized anything like this knows that this is highly uncommon. Like, you are struggling to fill up the existing chairs. So this worked out perfectly well, and we are going to continue that. Now let's look at a couple of modules that we have introduced in our Fundamentals of Engineering Design 101, FED 101 course. One was sort of enhanced and developed based on the EOP framework. Other one is also based on the EOP framework, but we were doing that even before our grant award last year. So the first one is Inclusive Engineering Design, Sustainable and Ethical. Students have already gone through introduction to engineering design process. They have designed a couple of things, and middle of the semester, we want to introduce them to making their designs inclusive. We do it through a series of case studies and examples of how people have done it very well. Here is an example of desk that is, designed to be highly inclusive. We show them a series of many other examples that also are trying to do the best they can. So we have a smog vacuum cleaner. We have a convenient walkthrough at the airport security. We have implants. We have the Apple voiceover. We also have the mobility for initiative by Toyota. So my favorite one is the middle one on the top. This sort of highlights the fact that many of the household items are primarily designed for right-handed people in mind. And I have a standing joke that goes with this. I ask students to raise their hands who is left-handed, and I ask them, do you guys feel left out? And it has worked every time, every semester. So this is very relatable, and they start thinking about this. We also show them the bad examples. So this is a very famous viral video of a soap dispenser in Facebook during the pandemic. So this soap dispenser basically would not dispense soap for dark skinned people. It's like you have to really see it to believe it. This was uh, a major design flaw, and the dark skinned person actually grabbed a white paper napkin and it dispensed. But when he used his hand, it wouldn't. So we show them how engineering design sometimes fail. The other example is the Airbnb's Project Lighthouse, where they discovered that there was a booking bias where some owners were rejecting bookings from people based on their last name, and they used machine learning, data science, and engineering to push back and tackle that. So this is stuff that students get excited about, and we have a very nice group activity to get them to think about somebody else's design, not their own. So this is a well thought out activity where they start out on their own. They think of a product related to their major. These are interdisciplinary teams of 2 to 3 students. They think about, is this product doing enough to be sustainable, ethical, inclusive? And then they pitch this product to each other, and the group has to pick one product and make a short presentation of what it does well, what it can do better, and if they were to redesign it, how will they go with this. And I couple this with an active learning activity where the first part, individual preparation, we give them 15 minutes of class time. So no group has like not gotten started. We call this milestones based approach. It has worked very well for me, and I strongly recommend it for everybody. The second example is the societal impact of practice of engineering. This is a very key to introductory courses. In particular, we use a different case study every couple of years. We have used the COVID vaccine. Currently, we are using climate change, but I have to think of a new one for fall. So if there are any suggestions, they are welcome. We tell students about what's going on, and there are many opportunities for engagement here. I show them this image, ask them, when do you think this was published? They guess. And then I show them that this was published in March 1912. So we have known this for about 115 years, but we are talking about same thing. So what have we done? Then I take them to like our neighborhood. This is Hoboken. This is a really cool animation of what would happen to Hoboken if Hudson River were to rise by 1, 2, or 3 meters. And they can relate to it. I have many students from Hoboken. And then we get them to do like a role play exercise based on, if you were working for city engineer of Hoboken, how would you handle this? So the city engineer, when we designed this, my colleague, Associate Dean Lucy Schwasi pointed out, was an NJIT alum. So this is high, a cherry on the top. And if you are working for her, how will you help her tackle this problem? Through engineering analysis, we give them these resources. One is the map that I showed. Other one is this interactive portal developed with funding from NOAA. And this portal lets you play with it, see what will happen. And then students have to come up with an activity where they are going to pick something like, public school, bank, and what would happen, how many will be underwater if this should happen. They have to come up with a very nice executive summary to help the city engineer come up with a game plan. A lot of this is summarized in our EOP poster, which is publicly available. I encourage you to take a look. The last example I want to talk to you about is a standalone course. This is a fantastic course I developed with my colleague, Dr. Agwenga. She's in our honors college. We are a team of 25 students, 5 teams who are working through different projects to help our neighborhood problem, which is also a Superfund site. So we have teams working on remediation, sampling, GIS, community engagement, legal aspects, you name it. So this is a full-fledged course example directly tied to ABET learning outcome. And lastly, I want to leave you here with try to do changes incremental. Don't try 10 things at a time. It's not going to work out. Do go ahead with approaches that you also agree with rather than doing it because somebody asked you to do it. Take advantage of the resources. Engineering for One Planet is one. ASE peer repository. Just search for sustainability. You will see a lot of resources, including GIFTS papers, which are like, here, go try in your courses. Great ideas for teaching students. Establish a culture and stick to it. Celebrate success, but make room for failure, align modules with student outcomes, and think about how can I replace, redesign, restructure activities as opposed to making room for it. I have so much content, or I'm sacrificing class time to do it. So if you did this, if I can do it, you can do it as well. Thank you very much. If you have any questions, I'll be here at the end. And I think I'm at the end of my time. So next up, let's hear what Dr. Pinar is doing in her wonderful courses. Thank you so much.
Thank you so much, Ashish. And I'm very glad to be a speaker of this AEESP webinar. And I'll be telling you a little bit about how I integrated sustainability reasoning into a core environmental engineering senior level design course, and how I use scaffolded writing as a tool for EOP competency development. I would like to give you a little bit of context on my institution. I'm from Colorado State University. Colorado State is a tier one research university, public university, and a land grant university. We have 8 colleges and about 2,000 faculty, and where we are educating 35,000 students. On top of these, I would like to also brag about CSU's legacy in sustainability. Colorado State University was ranked number 2 in the country and number 3 in the world for sustainability among higher education institutions in 2025. And in 2015, CSU became the first university in the world to earn a Platinum Stars rating for sustainability performance. And also, CSU was tied for the best interdisciplinary sustainability curriculum among all institutions listed in the 2024 Sustainable Campus Index, which is a publication of ASHE. And then I would like to tell a little bit about my program. In Civil and Environmental Engineering Department, we have 34 full-time faculty. We have about 18 million research expenditures as of last year, and we are educating about 650 students both in our undergraduate and graduate programs. And I know we have a really clear vision on this, but I would like to tell a little bit about why we would integrate sustainability into core design courses. It has been my experience that we usually treat sustainability, and I'll touch base on ethics as well, as an add-on. Typically a brief section at the end of a report, and really not embedded in decision making when our students are evaluating their designs. Also, we give less structure than technical analysis. We probably prepare our students much better. And usually our students lack scaffolding to reason across the environmental, social, and economic pillars. However, all of these challenges bring in the opportunity as well. As there was mentioned, EOP framework is a great source for inspiration, which was for me. And I was also very inspired by the writing across the curriculum offered by our university. And we can embed sustainability reasoning throughout our curriculum, as was discussed by other panelists, but also within a course as well. And I've been very involved with our accreditation and visit over the last year or two, and I know that it is also important, and it gives us the ability to be able to address several ABET student learning outcomes when we utilize the EOP framework as well. So I would like to tell you a little bit about my course. This course has been a passion project of mine since I inherited about 15, 16 years ago. This is a senior level core course, which is based on a project-based design, and it involves teamwork. We have teams of 3 to 5 students, and typically on a given semester, we have 40 to 60 students enrolled. It fluctuates a little bit. Last year, I had about 50 students. Next year, I expect 40. And how is this course structured? Again, it evolved a little bit. Rather than being a one big project where students wrote a report and presented at the end, I started scaffolding it with 3 reports so that everything would come together. I infused it with social and environmental justice, but with the more recent, like last 2 or 3 years, I've had the writing across curriculum redesign and putting a lot more emphasis on ethics and sustainability. This project is open-ended, and it is a little ambiguous so that it gives that process of our students struggling with coming up with the constraints and decision making and defining the problem. So our first report starts with problem definition, and they are asked to conduct a literature review to be able to really figure out the problem and come up with possible solutions. Um, then they move on to focusing on viable solution alternatives to their problem. This is where we really nail down and improve the sustainability reasoning and ethical considerations. And the last third part of the semester, they will be building on their decision making and reasoning, and they will run a cost benefit analysis and multi criteria decision analysis to come up with their final design, again, informed with that sustainability reasoning as well. And as I have mentioned before in this presentation, before I implemented more specific writing activities, the sustainability was just a part of a report, but the students didn't really engage with it. And we had minimal scaffolding and feedback for them to improve on their thinking and revising their sections. It was more served as a documentation than reasoning. And when they were coming up with that section on, they discussed the sustainability impacts of their alternatives. It was just as a final reflection, it was not a part of the decision making and maybe evaluating their designs to make them more sustainable or going for another solution altogether. And my experience was that when we had that bigger chunk of work due at a certain time period, they would just wait towards the end of that timeline and then rush through their writing and processing and did not get the benefit of processing throughout. And so after my redesign, we had scaffolded deliverables across multiple weeks. And I aligned the writing to the design milestones so that it would help them make progress. And with the writing across curriculum principle, I approached the writing as a cognitive tool for reflection and analysis and decision making. Another element that we incorporated recently last year was adding on peer and TA feedback, and they would get feedback on those individual deliverables so that they could revise them and implement a much better product for the report. And I will give you a perspective on how this works. Just building on what I have said, we start with the technical exploration. Again, everything is scaffolded in smaller writing activities and assignments. This first part where they explored the problem and the issues with that environmental problem and possible sources, this really aligned with the EOP system thinking and design process. Then later on, the intentional writing assignments asked for sustainability analysis. They explored the environmental, social, and economic dimensions, and this mapped really well with the environmental literacy and social responsibility. Building on to that one, we also wanted them to think about equity and justice implications, stakeholder impacts, unintended consequences, which maps really well with social responsibility and critical thinking. And finally, throughout these process, the deliverable chunks D1, D2, and D3 feed into the final product. They get a lot of feedback and they are able to revise their decision making and process and design, and which goes back to the EOP's design and communication and teamwork. I will give you a quick example for a prompt. So this was for considering sustainability and stakeholders. They would address these questions as a part of their writing assessment, and then what the products, the short writing assignment, they would be getting feedback from their peers within their team and the TAs so that they could engage with this even more as they were working throughout this process towards the report too. I know we are behind schedule, so I will be going forward and I would be happy to provide you with prompt examples or others afterwards, or also I'll pitch in my ASWE presentation as well. As I have mentioned, we just had our visit, ABET visit, in fall. So we have been doing a lot of thinking with mapping our courses and being able to assess student learning outcomes. And I think by just incorporating these scaffolded writing assignments, specifically focused on ethics, justice, and sustainability, allowed us to hit both the ABET outcomes and the EOP topic areas, as you see here. This is an example of the rubric I have developed to be able to really quantify the student learning outcome achievements and then move forward making other interventions and continuous improvement as well. And I'm really excited about the new framework because it also addresses the ABET outcomes and it allows the faculty to be able to be more mindful with their interventions and data collection and assessment. And going back to this rubric, after this iteration, it was very exciting to see that 78% of our students articulated the trade-offs between the sustainability pillars, two or more sustainability pillars, and 83% identified ethical and justice concerns and discussed the mitigation strategies, how their designs could be improved. If we could get the students engaged with the deliverables, actually, they would consider the three pillars coherently. However, the ones that were less engaged and also the previous iterations of this course, it would really focus on the economic factors rather than environment and social aspects. Most students gave feedback, and also my observation was that the smaller chunks of work really engaged the students more with the content. And I will briefly mention this at the end as well. Qualitatively, I thought that they did a much better job with their reports and findings compared to the previous years when they had the ability to be able to work on the parts of the project and smaller chunks. This is a work in progress. I would like to go back to my previous offerings and student reports from the previous times and compare the discussions and coverage of the sustainability pillars and trade-offs and ethics considerations. I would like to tell a little bit about the lessons learned from this process. Aligning writing with design milestones, I think encouraged students to work on the project more and reduced resistance, and writing felt more purposeful rather than it's just another assignment. I think scaffolding was really helpful too, building on top of each other. Again, I observed much better student work and a better appreciation of their teamwork as well, because everybody was contributing because they were in charge of their smaller sections as well. One thing I really realized was I have to, in my prompts for those writing assignments, really explicitly require the three sustainability pillars so that the students have that systems thinking and making the connections between the pillars. There were some barriers too. Some students, not many, but still some, perceive that this is too much busy work. So maybe in the future iterations, I will try to reduce the number of smaller deliverables, but still make sure that they maintain the momentum in making progress for the project. And another concern was TA calibration. It is important to give feedback, but I had two TAs because of the workload, and they were not calibrated. They were not on the same page, even with my best efforts. So the students would get a little different feedback and different levels of feedback from the two TAs. So providing meaningful feedback and also uniform feedback will be critical. A few other quick takeaways. I would highly encourage you to consider scaffolded writing to learn assignments to incorporate sustainability throughout the design. This could be throughout the curriculum, or this could be just throughout a course. And they are easy to map to ABET student outcomes and the EOP competencies, especially that it is already ready for you to adopt those learning objectives. I think that those smaller bits improve the student work, and with this kind of approach, my experience has been minimal course structuring, so it was really doable. So I would highly recommend to consider this for other civil and environmental engineering or other engineering design courses. and I'd be happy to share the rubrics, prompts, and assignment structures, especially that I will be presenting this work this summer at the ASEE conference. But I also would like to acknowledge the support offered by the Writing Across Curriculum course development grants at CSU and the School of Global Environmental Sustainability Curriculum Innovation Grant as well. With that, I thank you so much for your attention. I think all of the panelists are looking forward to your questions. So we'll go back to the main room.
Thank you, panelists, for really great conversations. We are promoting you all to be panelists so that you can show us your video, raise your hand, ask questions. So you don't need to decline our request if we're sending it in. So do we have someone that wants to lead off with a question?
Maybe can you comment on the chat if you would like to ask a question, if you are able to, like, are you able to unmute yourself?
Yeah, we can unmute. This is Sarah.
Yeah.
Okay, thank you, Sarah. Deborah has a question.
I have a question. These are great examples. Thank you so very much. And we're involved with a textbook project to try and get this all into textbooks so that people don't have to recreate the wheel with integrating it into the different courses. So I'm just wondering if the people who presented, have you compiled what you've done in such a way that we could then hand that to a textbook author and say, look, here's a way to do it. Here's some ways that it could be easily done so that they're not having to recreate from scratch. Just a thought. I wonder what you all think.
I think it would be very doable. Maybe we just need the initiative. So just give us the opportunity and we would be happy to contribute.
Yeah, my answer is actually it would be difficult. A lot of stuff that I have done is not really my own. I have relied on a lot of fantastic resources, and they have made it freely available as, go try in your classes, but it's not really my intellectual property. I can't publish it. It's already been published. Of course, I made changes, but it's not sufficient to be like an author in a book. Does that make sense?
Well, what I'm wondering is maybe we would go and ask them for permission, right? If you use somebody else's stuff.
Yes.
And because we're trying to target the best-selling engineering textbooks so we can have the most impacts on the most students.
Perfect. Yeah, that
Yeah.
should work.
Okay, great. Anybody else?
My end, I think that's definitely a possibility. It does frustrate me a little bit in process design textbooks that sustainability is just like a few pages at the end of the textbook. And the ones that are, at least the ones that I know of like sustainable process design, don't actually match my current program structure. So I'm like in the process, I think in the concept process of rethinking this. Textbooks are still like far away from my reality, given the tenure track and all the chaos that's involved. But I would be more than happy to sit and talk deeper about this.
Right. And once again, we're not asking you to be an author of a textbook. We are going to the authors of the best-selling textbooks, and we're saying to them, this is part of ABET criteria now. Can you integrate this in? And then they go, I don't know. And then we go, well, there's materials, right? So if we could share how you've done it, then they could integrate that in. And I assume give credit for where they take the examples from. So you kind of get the credit without having to do, all that work. But we can be in touch with you after this and see. Very excited about the possibilities. And yes, thanks for putting in. An author came into the chat too, and I don't have your email, Susan, but I assume that the Cindy's do and that they'll share it with us. So thanks. And you can also fill out that form. Yeah. Oh, and great.
How about any other questions? Do we have any others from the audience? Feel free to raise your hand, unmute.
If any of the panelists are already sharing their resources somewhere, if you all are collecting that, I would love to see that, beyond the webinar today. Like sometimes folks have already gotten permission to share student work or, anything related to what they presented today. I was fascinated by many of the presentations, and some I had already known, but I also learned more from them. So this was great. Thank you so much for organizing. And your dog is so cute sitting in the window behind you.
I'm glad you joined it, Sarah.
Yeah.
Others?
I have a quick question. Can you all hear me?
Yeah, go ahead, Pablo. We can hear you.
Okay, yeah, I don't know if you can see me or hear me. But yeah, so my question is related to the social pillar of sustainability. And I'm wondering, from your all perspective, what has been maybe some good ways for a group project to integrate the stakeholder perspectives? Do you actually, have you seen examples where, you have students go out and develop a survey with a Likert style ranking table of certain social or technical metrics to incorporate that? Or what are maybe some other strategies that you all have incorporated to address that specific pillar, which seems to be maybe the most esoteric for many engineers?
Yeah, I can take that if I may. So we are doing this. I had to rush through my last slide where I spoke about a service learning course. So this is an advising style course where we have 22 students. This time it was supposed to be like 3 students, maximum 5 students, but we are doing it. And I'm actually missing our weekly session in order to present here. So in that, we have students from science and liberal arts, we have students from architecture, we have students from engineering, and we have 5 teams. So engineering teams are focused on sampling and environmental remediation, whereas the other teams are focused on GIS mapping and virtual reality, as well as the history and the changes in law, community engagement. We had a team that hosted a table at the Cherry Blossom Festival this past Saturday, where they spoke to people who were attending, asked about does this bother them? What would they like to see? So this was not done in like a publication perspective where we had like a valid instrument and stuff like that, but we are doing quite a lot in collecting what do they want to see uh, done with these neglected areas of this beautiful park. And we got a lot of very good feedback, which is now communicated to engineering teams who are coming up with like concept designs and other stuff that we are going to hand over not only to the city, but actually NOAA currently has a competition that you submit student group projects, and then they are going to provide money to actually bring them to life. The deadline is April 30th, which works very well with our semester end. So this is a lot of work, and I'm actually very glad that I have a collaborator whose specialty is community aspect. As you pointed out, as a traditional engineer, I, I'm I'm able to explain to the community, but these some aspects were very alien to me, and I'm learning every day.
Yeah, and if I may add to that, in the course that I describe, it's a 1 credit freshman level class. And in that course, what I use is the master plan. And if I am working with a city, they have often had surveys out to the residents or even they have to their staff in their offices. And based on that, the students can look at that and they can start getting that community voice. Because of that time constraints, actually, this last year I dabbled into using AI generated personas for that particular project, and the students engaged with that persona, speaking about the projects and what their reaction was. Certainly, it doesn't reflect the lived experience, but at least as a freshman level starting point to understand the bigger picture. And the students were surprised in some areas, and it was good.
And I do have an example of an impactful activity. We talk about social and environmental justice, and we used to use EPA's environmental justice screening tool.
Yeah.
Now it's not working, but there is a copy of it, and students observe the impacts of pollution and who carries the burden of that pollution, and they come up with their own reflections and observations. And I think that has been very, very impactful, and that they can really tie it back to our discussions as well.
I would love to just add to, in answering Pablo's question, on the Implement EOP website, I'll put this in the chat here. That's where you can find all of the EOP resources, the framework, as well as the companion teaching guides. And in every one of the companion teaching guides, there is a reference to the one of the 9 topic areas, which is social responsibility. And each one of those activities is an example of an activity that's around social sustainability. So you may find something of interest to you in looking at those teaching guides. And again, they provide step-by-step activities, examples of assessment, prompts, that sort of thing. So hopefully they'll be useful to you.
So much, Cindy. Do we have any other questions
Yeah.
from the attendees?
I have a question. Are you able to hear me?
Yes, Cliff.
Yes.
Great. So I put a little note in the chat that there has been a lot going on at AEESP conferences with regard to sustainability. And I'll just mention that a small group of us has put on a workshop on integrating sustainability into core engineering courses. And we've had a lot of participants. But it's interesting, we have not interacted with the education committee at all, and we should certainly do that. And also I have seen listened to some presentations of others that have done the same, putting sustainability into their courses. So I think there's a lot going on right within AEESP, and we can probably do more to integrate all of our individual efforts. And certainly the education committee is a good place to do that.
Thank you, Cliff. As part of the education committee, we would love to hear more about it, and maybe we can promote this within the educational community or help inform the next groups and so on and so forth. So I think it's a natural connection that we can make happen.
Well, I just got to say, Cliff Davidson is the grandpa of all of this. He is the grandfather who set up amazing programs, 2 decades ago? So glad you're here. That's a fantastic offer. And just kudos to Cliff for being such a pioneer.
And can I just quickly pile on to Deborah's comment? Because Cliff, hello. I don't know if you remember me, but I interviewed Cliff before we launched the Engineer for One Planet framework. We interviewed over 100 leaders in sustainability, and Cliff was one of them. So hello, Cliff, and just know that you strongly influenced the EOP framework and what came out of it. So thank you so much.
Well, that's great. I think we can do probably more to work together, and that's probably something I should take the initiative on. So I will do that.
Well, I would like to thank again everybody and our panelists. Thank you so much for these wonderful presentations, very rich content. Thank you to everybody that attended the webinar today. I hope we can all keep doing this. We may have another one in September, so stay tuned for that. I hope you can see my screen here with all the emails for the individual presenters as well. If you would like to get in touch with them or have any other questions, please feel free to reach them through email. And with that, we are on time, so we need to wrap up. Again, thank you very much for being here today. And I look forward to see everybody in September when we do it again.
Thank you.
Thanks so
Thank you for
much.
the opportunity.
Bye. Thank you.
Bye.
Thank you.